is integrated 3. It's problem 10-54. It says write each series in sigma notation and calculate the sum or an expression for the sum. So they give us this, these are arithmetic, both of these, arithmetic series, and then they want me to put it in this funny sigma notation, which I think that I gave you a video for this one already. Let's look. 10.1.4. Yeah, there's a video up for this already that explains how to do this. So you can look under my YouTube channel and look for the one that says lecture on 10.1.4. But I'm going to go through these. I've written them down on paper right here. So this is just the sequence. So the first thing you want to do when you're trying to get it into sigma notation is you need to find out what's the rule. So I counted that it was going down by 13 every time. So that gives me the slope. Like if it was a function, it would be like y equals mx plus b. So whatever it's changing by is whatever it's adding each time is the slope, and then the y-intercept is a 0th term. So what would I have to subtract 13 from to get 47? Well, basically I just added 13 to 47 and I got 60. You don't have to do it in that form if you don't want. You can start with the first term, and then you can add the slope times x minus 1. Because you'll see if you distributed this would be negative 13x, and then negative 13 times negative 1 is positive 13. If you add that to the 47, you're going to get your 60 back. I like using this form because it's easier for me to plug numbers into. So I just go ahead and go with this. Really, this is not a function. This is a series. So I should be using t of n and n. In my answer, I'll make sure I write it correctly. So basically, summation notation, this is a Greek symbol sigma. And when you write this, it says that you're going to add up sum, get it? Sum. You're going to add up the first term plus, it goes in integers, the first term plus the second term plus the third term plus the fourth term plus the fifth term plus the sixth term plus the seventh term plus the eighth term plus the ninth term plus the 10th term plus the 11th term. So it's saying you're going to add up each term all the way up. That's your ending number. That's your starting number, and that's your ending number. So this is always your first term, and this is always your last term number. Not the y value, but the x value. It's the term number, okay? And then you write the rule right after your sigma. So it tells you, like, basically the first term I'm going to plug a 1 in. Negative 13 times 1 plus 60. 47. And then I'm going to plug in a 2. That negative 13 times 2 plus 60 gives me that. And then plug in a 3. And keep doing that. Plug in a 4 and a 5 and a 6. And add all those up. And the last thing I'm going to plug in is an 11. Which is going to give me some really big number. 11 times negative 13 plus 60. It gives me that number. And so where did the 198 come from? So I had to do some work to get the 198. Oh, and how did I know that was the 11th term? I used this. I plugged in negative 83 for y, and then I solved for x. So subtracted 60 on both sides, got negative 143, divide by 13, and I got the x. So that's how I knew that was the 11th term. So I couldn't have written that up there until I did this little bit of work right over here. And then I already had the rule. I got the rule by, looking at what's the slope, what's the y-intercept, because it's arithmetic. And then I have to sum, the 198 came from summing them up. So we've been studying this. We know that you can take the first one plus the last one, and you get some number, and that'll be the pairs. Like all the pairs are going to add up. Like the 11th term plus the, here, let's do this. What take away 13 makes negative 83? This term, the 10th term, was negative 70. So what I'm saying is there's these pairs, like the 47 plus the negative 83. That made negative 36. Well, guess what? The 34 plus negative 70, that also makes negative 36. So I hope that by this time you realize that if it's arithmetic, these are going down by 13. These are going up by 13. And so when you pair them up, you get all these pairs of negative 36. How many pairs do you get? Well, there's 11 items in the list. So everything's going to pair up, but there's going to be one like loner in the middle that doesn't pair up. So, but it's okay. It still works. So that's where this summation, where this to find the sum of the however many terms of a sequence, if it's arithmetic, it's always n over 2 times first plus last, the first term plus the last term. So that stands for how many pairs there are. This is where I get my negative 36 from. The first plus the last, they're pairing up like that. And then, so if I do all that work, that's where my negative 198 came from. So that's, you write it in summation notation, and then you say the answer. And this right here is the answer to the question. And then letter B, they're trying to do something tricky. They don't give you the last term. They say, here's your sequence. So what's happening with my sequence? It's adding 7, right? But they already gave me the rule. It's adding 7. If I went backwards, I would subtract 7. That's where that negative 4 came from. So I can go ahead and make my summation symbol. And then there's no way for me to find out what term this is. It's just the nth term. So I'm going to sum up the terms from the first term, the second term, the third term, all the way up to the nth term. This is the rule. I had to name it something. At first I wanted to name these n because I like calling them n, but I can't because I'm already using n right here. So I had to use k. So, and actually I think that your book likes using k, so we're just going to start using k for that. So I got 7k minus 4. So that's saying the first term I can get by plugging a 1 in. Gives me the 3. The second term, I plug a 2 in, I get 10, right, like that. And then the sum of that would be, here's our little formula. Our little formula is, these are the pairs, and then the first plus the last. So the first term is 3. The last term is 7n minus 4, but the 3 and the negative 4 make negative 1. So there it is. I don't know how many pairs there are because I'm just going all the way up to the nth term, so I just have to leave it as an expression. So this right here is your answer.